Thank you. Good morning, and thank you for having me. I am Alice from the University of Turin in Italy. Today I will talk about two studies. One is the one that we submitted, plus a little surprise, I hope. So let's start from the background. So when we talk about motor development and very early in life, so in newborns, we refer to afinalistic, so spontaneous movements. And previous pioneering works already showed that when we talk about infants in the very first months of life and also in fetuses in the last period of gestation, they frequently engage in a very special form of spontaneous motor behavior. That is, they frequently bring their hands towards the own body, and this is what we call self-directed movement. And they also tactilely explore the self-body, performing the so-called self-touch. And although this behavior hasn't been yet confirmed and quantified, in newborns just a few hours after birth, the clinical observation of neonatal spontaneous movement suggests that this kind of directional behavior should already be present at birth. So, just previous distinguished developmentalists already hypothesized a crucial evolutionary meaning of this kind of behavior. That is, by bringing the hands in contact with the own body, infants might explore and have the unique opportunity of exploring their intermodal redundancies that pertain to the bodily self only and not to others' bodies. And so this might be a motor context useful for developing early multisensory body representations. So based on this background, I present you today these two studies. In the former, we aim to quantify and characterize this self-directed neonatal motor behavior just a few hours after birth through a kinematic study, while in the second experiment, we aim to describe a possible modulation of multisensory bodily integration within this motor context. And the idea behind these two studies is that if self-directed movement is so crucial in building the body representation, then newborns should engage more in this kind of behavior as compared to its opposite, so the movement aimed towards the external environment. And on the other hand, also the integration of multimodal stimuli converging on the own body should be enhanced within this motor context. And both these studies belong to a broader project, European project called My First Body, in which we study how the motor development shapes body representation emergence. So, starting from the first study, here we video recorded a lot of newborns between 11 to 72 hours after birth, lying supine and freely moving without any constraint. And then we performed a manual scoring of the hands' directional movements. Specifically, we coded them into self-directed movements when the hand approached a body part, and externally directed movements when the hand aimed towards the external environment. We also coded for the bodily target of the movement and also whether the self-directed movement ended with the body contact or not, but due to time constraints, I will only talk about the first analysis today, but I'm more than happy to discuss it after. And lastly, I want to mention that thanks to a collaboration, because for now we have only coded 14 newborns out of the 45 newborns of the dataset, because, as you know, manual coding is really time-consuming. But thanks to the collaboration with Matej Hoffmann and his lab, Khoury and Filipe Gama, we're now building a semi-automatic way of scoring these movements to score also the remaining datasets. And also, thanks to their help, we were able to track the velocity profiles of the manually scored datasets. So, moving to the results, the first analysis that we did was simply comparing the number of self-directed movements in pink, red, to the number of externally directed movements, here depicted in blue. And as you can see, all our newborns but one, so a very consistent pattern, show greater number of self-directed movement. But these movements were not only different in quantity, but also qualitatively, since the mean velocity was decreased. And when we analyzed the velocity profile, we saw that this decrease was pertained to the last 50% of the movement. So as the hand was reaching towards the body, they decreased the velocity. So these results somehow indicate that newborns do engage in this kind of behavior, and they also, an interpretation that we gave of the velocity results is that they might anticipate the sensory consequences of their actions towards the body, and so decrease the velocity to avoid possibly overly forceful tactile contacts with the body. So moving to the second study, basically here we wanted to describe a possible electrophysiological modulation of body-related multisensory integration during this kind of self-directed movement, and to do so we relied on a previously devised experimental paradigm that was devised in our lab and applied successfully to newborn firstly. So my colleagues at the Manibus lab, basically they exploited this audio-tactile multisensory integration paradigm, and the idea behind this is that when multisensory integration entails a stimulus that is inherently bodily, like a tactile stimulus, and is combined with an auditory stimulus, so an external stimulus, if the multisensory integration of these two stimuli is enhanced when the auditory stimulus is near to the body, this means that multisensory integration is enhanced within the peripersonal space as compared to stimuli delivered outside the peripersonal space. This can be exploited as an implicit marker of a well-developed multisensory body representation. And they did find this biomarker in newborns. So based on these results, here we wanted to tackle whether self-directed movement could be a developmental context that promotes the development of this multisensory body representation. So we basically used a very similar paradigm to the one previously devised. So before each trial, this time, we moved the newborn's hand either towards the baby body, so as to perform a self-directed movement, or away from it, so as to perform an externally directed movement. And with a random delay, we then delivered auditory, tactile, or audiotactile stimuli, as in the previous study. And so this yielded to 5 conditions. The first condition is an auditory condition in which we just measure the event-related potentials with electroencephalography to the auditory stimuli alone, delivered near to the body, always in the same position. Then we have tactile and audiotactile self-directed conditions in which a tactile stimulus on the baby's hand is delivered alone or coupled with the auditory stimulus, and again electroencephalography is measured after the self-directed movement, and then we have the very same conditions, but after the externally directed movement. So this design allowed us to test 2 effects. The first one is the classical multisensory integration effect that is present when the electrophysiological responses to the bimodal audiotactile stimulation is greater in amplitude as compared to the responses to the unimodal stimulation, so tactile and auditory delivered in isolation. And we expected to find it since the previous study already showed it in newborns, but also we could also investigate a movement-dependent modulation of multisensory integration, because if this multisensory integration effect is greater following the self-directed movement, this would end up in a movement-dependent modulation of these processes. So, jumping to the results, I hope you can all see that we replicated the previous study, because the darker curves that represent multisensory stimuli responses are greater than the sum of the unimodal, which are the lighter curves. But interestingly, this multisensory integration effect also interacts with the direction, so it's boosted, it's greater following the self-directed movement in red. So, to conclude, with these 2 studies, what we show is that newborns do engage in this self-directed behavior a lot, and they seem, or at least this is our interpretation, to anticipate the sensory consequences of this action towards the body, and this supports the idea that this is a motor context allowing the exploration of intermodal, multimodal redundancies. And also we show that body-related multisensory integration is enhanced within this motor context. And again, this supports the idea that these movements promote the building of a multisensory body representation. And to conclude, an interpretation of this study, but also many other studies that have been presented, is that bodily self-exploration seems to be to act like a developmental play gym that allows to learn about the self, so to build body representations that, and also many other abilities like reaching towards the body and grasping the body that can then be transferred to the external objects to interact with the world. And fortunately, the good news, we have also longitudinal data from these babies, which hopefully I will present in the next conference. So with this, I'd like to thank all of my colleagues from the Manibus Lab, our collaborators here in Prague, Matej Hoffmann, Jason, and Filipe, our fundings, and of course you for your attention.
So, do you have questions?
Thank you. Thank you very much. Very interesting work and very clear presentation. Thank you. My question is about the first study. Mm-hmm. So you show a reduced speed when of the movements that are approaching the body, and you have this possible interpretation of the anticipating the consequence. Do you think there could be other reasons? So I'm thinking, for example, biomechanical constraints. Then when you approach the body, the kind of you get closer to the joint limits, let's say, of the body, and you kind of the motion is impeded by the rest of the body, and so maybe it slows down also for that reason, or other things. Thank you.
Thanks for the question. This is something that we also thought about a lot, because you're right. It could be that when you do self-directed, the constraint somehow reduces the speed. So we did we did further analysis, and to corroborate somehow to support our interpretations, we analyzed the different bodily targets, and so the decrease in speed across different bodily targets, so the head, the mouth, and the trunk. And basically I should also have, yes. And here in the left part you can see these are not super good, but the velocity profiles of the single bodily targets. And as you can see, it seems that the velocity decrease is also, the velocity overall is modulated as a function of the sensitivity of the bodily location. So here it's all self-directed, so it's, let's say, the biomechanical constraints are the same, but still the velocity is modulated by the sensitivity of the bodily site. So this is not a demonstration, but this supports the idea that it's the anticipation of the tactile contact that guides this velocity modulation and not the biomechanical constraints. But I agree that they also play a role. Thank you.
There's one here and there.
Hi, yeah, thank you for the talk. I guess what I'm wondering is, it seems like they kind of already have this schema, like they're already making these predictions. So I guess like, where do you see that schema coming from? Is this coming from self-directed movement, like prenatally, or I guess like what is your guess about the story there?
Okay, thanks for the question again. We know that these spontaneous general movements are present also prenatally, like the clinical evaluations of these movements have been done already prenatally, and there's this anecdotal study, but interesting, by Castiello and colleagues that shows a greater number of self-directed movements also within the womb. If I'm not mistaken, around the start of the second trimester, so very early. So probably this could be the reason why they already have at birth this body schema, but also it could be the other way around. I mean, this is not a causal inference that we do, because we see that when there's the movement, then there's the body schema, but we don't know which one drives which. So the idea within the broader project is also to test people with motor impairments and motor deprivations to see whether they have the body schema. So if the motor part is the one that drives the emergence of the body schema part, then if you have a deprivation or an atypical development of the motor part, then you should have atypical, at least, body schema. So, thanks.
Well, I guess this is a continuation of that question as well. So in this self-directed movements, and you're mentioning as well that they are having this anticipation of what would be the strength of touch. So that involves as well having either the body schema or a knowledge of what will happen, these causal actions. And this is like pre-loaded expectation, or at least assuming that there's already some either rough model of what should happen is basically the conclusion or hypothesis that could be drawn from this?
Yes, this could be drawn. I'm always, I hesitate to say that they have motor control in the womb, or at least at birth, because, you know, they're just born. But yes, the idea behind this is that they should have some very primitive knowledge of what is going on. And for testing this, we have also another line of research that exploits, I don't know if you know the sensory attenuation paradigm. You measure the responses, the electrophysiological responses of self-generated or other-generated touch. And here we built like a self-directed, other-directed paradigm, a version of this sensory attenuation. And if the consequences of the action are well predicted, then the amplitude of the response, or in the adults, the perception of the touch, should be decreased. So we will see, this is like a marker of the ability to predict the consequences of the action. So we will soon discover if that's correct.
Thank you.
So let's applaud our speaker.
Thank you.